So good afternoon, good morning, good evening, and welcome to the first ITU Ask the Expert session of the ITU Digital Transformation Dialogues. So today's session is part of a larger ITU series called the Digital Transformation Dialogues. The Digital Transformation Dialogues include webinars, fireside chat, and Ask the Expert sessions, such as these, where we bring a leader in an emerging technology field to share your thoughts on important topics, such as digital twin in cities. So we encourage you to keep an eye out for our upcoming events, which I'll give you more details about at the end of the session. My name is Cristina Buedi. I am an ITU counselor, and I'm happy to be the master of ceremony for today's session on digital twins for smart cities. Cities are increasingly embracing the integration of digital twin into their urban ecosystems. Thus, establishing common practices and international standards is imperative. Today, our special speaker will be discussing how ITU can help ensure seamless interoperability, data security, and sustainable growth, and therefore are a key part in the standardization of this technology. Finally, before we begin opening remarks, I would like to highlight a few logistic items. So throughout the session, all questions from the audience will be taken from the Q&A window, not the regular Zoom chat. The Q&A icon can be seen at the bottom of your screen. In addition to your question, please also indicate the city and country you are connecting from. And if you would like to revisit this conversation later, I would like also to highlight that the session is being recorded, and both the recordings and slides will be made available on the event website. So thank you very much for your time and attendance. I will now turn the attention to the Director of the Telecommunication Standardization Bureau, Mr. Seizo Onoe, who will be delivering today's opening remarks. Director, floor over to you.
Thank you, colleagues and friends. Thank you for joining us. It's my great pleasure to welcome you to all the very first Ask the Expert session for our digital transformation dialogues. Our digital transformation webinars have been very well received, and we are building on this success by adding a fireside chat and Ask the Expert session to our program for 2024. Your feedback on your experience would be most welcome. As we continue developing this reshaped program. Today, we will look at the digital twins and the exciting opportunity they create for smart cities. In urban planning and management, digital twins are helping city leaders to simulate their innovations before implementing them at scale. Digital twins and virtual worlds could also enrich our experiences of city life and support collaboration among city leaders, companies, and communities to achieve our city's development goals. ITU standards are helping to create global access to these capabilities. Today, we will gain expert insight on these standards from Jun Sub Lee at ETRI, who leads the Question 1 working group within ITUT Study Group 20, our standardization expert group for the Internet of Things and smart cities and communities. Mr. Lee, thank you very much. We highly appreciate your support. Before diving into the digital twins, we will receive an introduction to ITUT Study Group 20 from the group counselor, Christina Betty, and I encourage you to reach out Ms. Betty following this session, should you wish to know more. To everyone joining us today, please don't be shy. Your questions will be the driving force for our discussions. With your help, this session can highlight the great value that ITU standards can bring to your cities. Thank you.
Thank you so much to the TSB director for these insightful remarks. It is really an honor to have you at our first Ask the Expert session. And I'm particularly pleased because as it was mentioned by the director, Junsup Lead is leading work on digital twin, in particular in ITT Study Group 20. So I would like to kindly ask my colleague, Jachi, if she could display the slides. I would like to share with you some information on the topic before we will delve actually into the standardization work. And indeed, in this transformational and digital transformation journey, international standards are crucial for a secure, regulated, and interoperable future. So in this regard, Study Group 20, ITT Study Group 20 is actually the lead study group that has been working to develop standards and guidelines to help cities in accelerating their digital transformation, and in order actually to enable the solutions, especially in the fields such as IoT, digital twins, and artificial intelligence. Digital twin, maybe if you can move to the next slide. Digital twin is a technology that plays a pivotal role in shaping the future of smart cities. Many cities worldwide have been using it. For example, Singapore, that is using a 3D digital model that helps actually city officials to simulate different scenarios. So for example, they're able to see how the traffic flow is doing and eventually make adjustments accordingly, or also to make some plan for urban development. Or if we look at how digital twin are being used in Victoria, In this case, for example, it helps really to visualize the impacts of future development. So city planners are using it really to create 3D models of infrastructure projects. And for example, if we change continent and we really look at Helsinki in Finland, that is using digital twin actually to create a comprehensive model of the city's infrastructure and services. So that really allows also, you know, proper planning. And in this case, we have seen that digital twin have an amazing power actually to help future cities to become smarter and more sustainable. And if we can move to the next slides, but in this efforts, of course, international standards are crucial to make sure that, for example, that technologies are, you know, interoperable, ensuring that the various technologies can work seamless together, allowing for interoperability, allowing, of course, for security, and ensuring that the future of digital transformation is open and accessible to all. The next slide, please. And the ITT study group 20 on IoT and smart cities is really the lead study group in ITT that is working to develop actually the standards and the guidelines needed for cities to help them in these efforts. The study group has also 5 regional groups. And it is mainly focusing on 4 lead areas, including IoT and its applications, smart cities and communities, IoT identification, and then digital health related to IoT and smart cities and communities. And definitely, I'm pleased to say that the presentations that I'm delivering, as well as the presentation that will be delivered by Dr. Lee, will be made available on the event website. Next slide, please. So if you have any questions or if you would like to find out more about what ITT SG20 is doing, please do not hesitate to contact us. And without any further ado, I would like now to turn your attention to Mr. Lee, so that he can introduce us actually to the work that SG20 is doing, in particular on digital twin. So Dr. Lee is the director of the Intelligence Convergence Research Laboratory at ETRI in Korea, and he's also the rapporteur of question 1 on interoperability and interworking of IoT and smart cities and communities application and services. And Mr. Lee will draw on his expertise to offer insights into the impact of digital transformation in city life, especially within the realm of digital twins for smart cities. So with that, Mr. Lee, over to you. Thank you.
Okay, thanks, Director and Christina. Good morning, good afternoon, and good evening, everyone. Excuse me. Can you hear my voice?
Yes, we can.
Okay. Okay, I'm Junseop Lee. I'm the editor of the IT recommendation Y.4600, which will be introduced shortly. And as introduced, I'm the question rapporteur of question 1 of Circuit 20, which is mainly for interoperability and interworking of application and services of IoT and smart city and communities. So during the last couple of years, question 1 of Circuit 20 has been developing recommendations for digital twin federations in smart sustainable cities. So So today, I will introduce ITUT activities on digital twins for smart cities. After that, I will introduce 4 ITUT recommendations on digital twins for smart city. Okay, recently, ITUT has developed or is developing more than 23 recommendations or supplements, which is related to digital twins in various study groups, such as study group 20, study group 17, and study group 11. Okay, so among them, 12 recommendations or supplements are closely related to smart sustainable cities. And all the recommendations and supplements in study group 20 are closely related to smart cities, and also 2 recommendations in study group 17 are related to smart city. I mean the digital twin for smart city. Okay, this is the current landscape of digital twin for smart city in ITUT. So as shown in the previous slide, currently there are 12 recommendations or supplements on digital twin for smart cities. So there are 3 deliverables for concept of digital twins for smart city. The first one is in the very bottom, Y.4600, which is defining requirement capabilities of digital twin system for smart city. Second one is supplements for use cases of digital twins in smart cities. Last one is the technical report, which provides the best practice for graphical digital twins of smart cities. Based on these concept things, ITUT is developing recommendations for specific verticals. Currently, there are 4 recommendations: work for transportation domain, firefighting domain, and water domain, and lastly, complex and campus domain. So as you know, the city is a system of systems. That means interworking between multiple domains is very important. Therefore, interworking between different digital twins for each domain is essential also in the city. For this interworking, ITUT developed 3 recommendations for digital twin federation, and it was approved a couple of months ago, last September. So ITUT is also working on security issues on digital twins and also security issues on digital twin federations. From the next slide, I will introduce these 4 recommendations shown in red, which is Y.4600, Y.4224, Y.4489, and lastly, Y.4605. The first one, Y.4600. It's titled as Requirement and Capabilities of Digital Twin System for Smart City. So ITUT Y.4600 is the first ITUT recommendation which defines definition of digital twin. In this recommendation, digital twin is defined as a digital representation of object of interest, with a note, which is also part of the definition, saying that a digital twin may require different capabilities, for example, synchronization or real-time support according to the specific domain of application. So smart city digital twin is defined as a digital twin for smart city, which can be used to develop strategy to achieve a specific goal of smart city by conducting simulations before actually implementing the strategy in the city. So in Y.4600, based on the city data, smart city digital twin system conducts simulations on the virtual city to find the best strategy or best combination of strategies and optimal parameters of the chosen strategies before implementing the strategies and plan in the real cities. So they, by this, they can save a lot of time and money in the city. So for the simulation on the virtual cities, the smart city digital twin needs to accurately represent not only the static object or passive object of the city, such as land, geographical area, street, buildings, and public spaces, but also moving object or active objects such as citizens, buses, and bicycle, which is moving around within the city. Y.4600 identified the requirement and all the capabilities of digital twin system for the smart cities, and it can be referenced to implement digital twin system to help urban planning. Next one is the Y.4224. So as I mentioned, ITUT developed 3 recommendations for digital twin federation a couple of months ago. The first one is the Y.4224, which defines the concept of digital twin federation and identifies technical requirements for digital twin federations. Technically, digital twin federation is sharing data and functions for collaboration across the different digital twin. So digital twin federation can provide valuable benefits for the smart sustainable cities, such as support identifying and responding to the cross-domain problem, or support integrated simulation to provide predictive services across multiple domains, support multiple phased decision-making among various stakeholders. Lastly, support identifying correlation and mutual side effect occurring across the domains. In the figure, the federated digital twin 1 is an example of digital twin federation, which is federating data A1 and A2, function A1 and A2 in digital twin A, and the data B1 in different digital twin B to provide new services that the digital twin A cannot provide by its own data and functions. So digital twin A can, federate, can use data B in digital twin B by federating each other. This slide shows the service scenario of digital twin federation for emergency response by sharing the data and functions between a digital twin for emergency medical care and the other digital twin for traffic. For sharing the data and functions in the digital twin for traffic have to be pre-registered or known to each other. So in step 1, the digital twin for emergency medical care and digital twin for traffic register their feature information into the registry, respectively. And from step 2 to step 4, digital twin for emergency medical care can perform the necessary functions by itself. For example, sending emergency resources, obtaining the information of emergency situation, and searching for the most appropriate medical institution, hospital. So for searching the most appropriate route to the hospital in step 6, it needs to discover and select required data and functions in other digital twins based on the feature information registered in step 1. So as a result, it will be noticed that the digital twin for traffic can provide required data and functions. It sends the request to the digital twin for traffic for searching the most appropriate route to hospital and receive responses with the searched route. So also during the transferring the patient to the hospital, it can be supported by the digital twin for traffic. Digital twin for traffic controls the traffic lights, traffic signals according to the location of the emergency vehicle. So in this service scenario, digital twin for emergency medical care is initiating digital twin, and digital twin for traffic is participating digital twin. Those two terms are used for who is initiating and who is participating for the federations. Okay, based on the identified requirement in 4224 in previous slide, ITUT Y.4489 defines reference architecture of digital twin federation. So first of all, it identifies all the necessary components for the digital twin federation. For the digital twin federation, registry and communication adapters are needed. So registry is a component registering the feature information of each digital twins and also providing the registered feature information according to the request from a digital twin. So as you can already see, saw in the scenario in previous slide. And communication adapter is a specific component which providing indirect communication in between digital twins. The indirect communication is used in the case when the digital twin cannot establish direct communication because of kind of difference of protocol or difference of data format or using different semantics. So in this case, communication adapter can provide indirect communications between the two different digital twins. Okay, then these recommendations, Y.4489, define the reference architecture of digital twin federation, including functions and functional entities of digital twin, registry, and communication adapter, which are already identified in the previous slide as a component of digital twin federations. It also identifies interfaces between the functional entities and explain which requirements in Y.4224 the functional entity is based on. The further details of functional entities, please refer ITU2 recommendation Y.4489. All those three recommendations, I mean the four draft recommendations are publicly available. It's free. You can download it. You can check that on more details. Y.4489 also define 7 basic operations of digital twin federation between those components. The first one is the feature information registration between digital twin and registry. And second one is the feature information registration between digital twins without registry. So in this case, digital twin each other have to register their information in opposite digital twins. And third one is candidate digital twin discovery. Next one is the direct communication establishment and indirect communication establishment, and direct information exchange and indirect information exchange. Those are 7 basic operations for digital twin federation. And the figure here shows the operation of feature information registration between a digital twin and a registry. So that's the first basic operation. And the last recommendation in is Y.4605, which defines the information exchange model and message structure for information exchange. For the digital twin federation, 3 different information exchange model can be used. In the pull model, the sender requests the receiver to send information, and the receiver responds by sending the requested information. In the push model, the sender notifies the new or changed information to the receiver without request or subscriptions. And the last one is the publication subscription model. After subscription procedure, the publisher sends the subscribed information to the subscribers. Basically, the use of these different 3 models for the operations are implementation dependent. So you can use different model for your operation. It's implementation dependent. The basic operation from 1 to 5 in the previous slide can be implemented using the pull model. And basic operation 6 and 7 in the previous slide can be implemented using the pull or push or pop model. So all 3 models can be used for basic operation 6 and 7. Okay. This slide shows message structures and list of actions, which is an operation or the response that is performed by a component of digital twin federation, digital twins, registry, and communication adapters. So the message structure for information exchange consists of the header area and data area, as you can see in the left side. The header area contains the all necessary information for communication, such as a sender, receiver, and timestamp. And the data area contains the action field and object field. The action field is contained an operations or a response that is performed by a certain component. For the action, it defines 8 actions. So change action is to request to a receiver to change the existing data, and connect action is to request to receiver to connect for digital twin federations, and delete to request to receiver to delete existing data on registry or on digital twins, and get action to request to receiver for sharing data, and process action to request to a receiver for processing on function, and register action to request to the receiver to register the data, and response to you can be used to respond which contain the result. And lastly, sync action is to publish new information or changes in existing information by the information owner to subscriber. So this recommendation provide detailed examples of message exchanges for the basic operations defined in Y.4489 reference architecture. You can also check that in appendix of Y.4605 or detailed example of actual message exchange. Today, I introduced what the standardization activities in ITUT is carrying out in the field of digital twin for smart city, including concept, various verticals, and federation between digital twins. Y.4600 is the first recommendation that defines digital twin, and it provides the concept of a smart city digital twin system. For the Digital Twin Federation, ITUT Study 20 developed 3 recommendations: Y.4224, Y.4489, Y.4605. So in summary, Y.4224 provides the concept of digital twin federations and also explain the service scenario of digital twin federation with the example of emergency responses. Based on the Y.4224, Y.4489 explains the components of digital twin federation, reference architecture, and basic operations. So lastly, Y.4605 explains pull, push, pop-up models for information exchange in digital twin federation and define message structures for digital twin federations. I think this is summary, and I think this is all for my presentation. Thank you for your attention.
Thank you very much, Junsub. I think that you gave us, a great overview of some of the standards that are being developed in ITU, and in particular, focusing on ITT Study Group 20. So we have several questions that have been actually included in the chat, and I would encourage once again all attendees to include their questions in the Q&A chat box. So let me start on one of the last questions, actually, on as an expert, would you please advise how long may take the process of implementation of digital twin for smart cities, and what may be the top requirements for that?
Okay, it's okay. Basically, the question is how long it takes to implement digital twin in the city. So it's depending on the granularity of the digital twins. So every digital twin don't need to be, have 3D modeling of the city. It's depending on their purpose. For example, in some cases, not just two-dimensional graphical representation is okay for their purpose. So it's depending on the, their the target. I mean, the purpose of the implementing digital twin. So it's various. And I forgot the second question from the Christina.
The second question is what are the top requirements for that?
So it's the top requirement is to clearly identify what is the purpose of the digital twin in the city. So as I mentioned, it's depending on the requirements, purpose, the required capabilities and functions are different. So you have to clearly identify what is your purpose and what is the performance or the KPI for the digital twin. So you have to clearly identify, and then you can implementing your digital twin in proper level. So that's the most important part, I think.
So I have also another questions on how important is the role of Internet of Things in the successful implementation and functioning of digital twins in smart cities?
Okay. Basically, the purpose of implementing digital twin in the smart city is, gathering the information and making a digital model in the virtual world, and they want to synchronize between real world and virtual world. So Internet of Things, IoT technology is key to gathering real world data, and that data can be used exactly modeling the virtual in the virtual space. So IoT technology is one of the key technology in the city for the digital twin. And furthermore, after the digital twin model is implemented, using the IoT technology to collect all the real data, furthermore, that can be implemented in the cyberspace as a whole, that can consist of, they can so-called, we said, cityverse or smart city in the metaverse. So IoT is the key enabler to actually implementing digital twins, and also making possible to synchronize between real world object and the virtual object in the metaverse area.
Excellent. I think that this brings us also to another question, which is being asked actually in the chat. How the ITU standards that you have mentioned here depend on the interface, on the air interface 4G/5G or other proprietary solution? There is a question in the chat.
Depending on the interface.
Are these standards depending?
It's not relevant. It's not relevant because in the digital twin, okay, if we have a 5G connection and very fast internet connection is good, but it's not depend on the network technology, underlying network technology. So what we we need some communication path, but it doesn't matter. It's 4G or 5G or Wi-Fi, whatever. So, but if we considering the digital twin, the synchronization, we need very fast speed for real-time synchronization between the real object and virtual object. We need 5G technology for the real-time synchronization. So yeah, that's the some case, but normally this is network technology independent one.
Excellent. And then there is another question that asks, one challenge in digital transformation in smart cities is ensuring robust cybersecurity measures to safeguard sensitive data and critical infrastructure from cyber threats. How this challenge may be handled?
Okay. Frankly speaking, I don't have much expertise on securities, but what I can say that in study group in ITUT, there's a study group 17, which is a dedicated study group for security. And as I introduced in the earlier slide, there's some security work is undergoing. For example, for the digital twins, they also considering some security issues, and also not only digital twin itself, but they also considering the security issues on the digital twin federations. And also for the Internet of Things technology, many security related recommendation for the Internet of Things is already published. So maybe you can download the relevant recommendation, and you can find some solution for that. I think that's all I can answer right now. As I mentioned, I don't have much expertise on security measure.
and maybe the other one is also on, for example, what are also the risks of normalizing digital twins in smart cities without establishing international standards beforehand, according to your views?
Yeah. Okay. In the smart city, there will be many different kind of different usage of digital twins. That means many digital twins will be available in the city. So most important one is to to provide interoperability or interconnection between 2 or 3 different digital twins from different verticals. So without international standard, it's not be possible to federate different digital twins. So as I mentioned, the city is the complex system of systems. So to solve the complex problem given in the city, we need to federate or collaborate between the different digital twins from different domain. So to accomplish that kind of interoperability, the international standard is essential, is crucial one. So that can be the answer for your question, I think.
And then there is also another question in the chat. Is blockchain proposed as a technology for the information exchange? Has it then been implemented according to your knowledge?
To my knowledge, I don't see any blockchain technology implemented in digital twin for the time being, but I think there will be some try, I think. So, for example, in ITU 2020, decentralized IoT technology is one of the rising issues. So somebody are considering it, but to my best knowledge, I don't see any blockchain technology in the digital twin right now.
And then if I can take also another question again from the chat. How does the development of digital twin affect the development of the virtual twin, and what are the factors that will play a major role in that?
Which question was that? I'm looking
Sorry,
for.
I see. I'm just reading in the chat. How does the development of digital twin affect the development of the virtual twin, and what are the factors that will play a major role in that? It's one of the last questions.
Okay. How does development of digital twin affect the development of a virtual twin? What are the factors that will play a major role in that? Virtual twin. I don't understand what the virtual twin means.
Maybe we can ask actually, Rakan, can you elaborate a bit more on your question, and then we will take it probably as a last one. And then maybe another question that I see on the chat is, for example, are you aware of any plans in place to engage governments across the globe for adoption purposes? I mean, we know that, for example, Korea is definitely one of the countries that is using digital twin, and is there, for example, anything that you can share about what Korea is doing, or also if you are aware of also other governments?
So if you look at the ITU recommendation Y.4600 in the appendix or next, there's some example of in Korean city case, the Sejong city, they are actually implementing digital twin for the urban planning. For example, rescheduling the bus routes, or how deploy the sharing bike or something like that. So they're actually using it, but it's been more than 3 or 4 years ago. So in these days they have more more services based on digital twin are implemented, I guess. And also if you look at some the journal papers, there are many digital twin implementation cases are available in various the country and city. And also in the slide presented by Christina Betti, before my slide, there's an actual example of digital twin implementation like Singapore and Netherlands and what was that, the other one, but yeah, that's the actual example of implementation of digital twins in the world.
Thank you so much. So I think that I would like I would like maybe just to take one last question, if I may. I know that there are really many that we have received, and thank you so much, by the way, to all attendees, because I think that it has been really great to have you so engaged. There is probably one last questions in terms of how, for example, if are there, let's say, any experiences or any good examples of implementation of digital twin in cities that you would like to suggest, also, so that maybe the attendees of this session, maybe they can do some research and then find out more. I know that one of the questions that remain unanswered, but maybe you can link it as well, is that we have been talking about the digital twin for smart cities, but is there something also about rural or remote areas, so that, for example, for those areas, how digital twin can be used?
Yeah, why not? So digital twin technology can be used in in a small town or small company, even in the small buildings, and it can be wider to cover the whole city. Even also it can extend it to the whole country, like Singapore, virtual Singapore cases. So the area and size of digital twin coverage is not so important, I think.
Excellent. So I would like really once again to wrap up by thanking actually Jin-Suk Lee for his insights, and also the director of the Telecommunication Standardization Bureau, Mr. Seizo Onoe. I would like to thank our audience for your attendance, for your active participation in this first Ask the Expert session, which had actually an amazing number of participants, exceeding our expectations. So thank you so much for being so many and being so actually active. I hope that you have enjoyed today's session, and we encourage you also to join our next webinar that will be held on the 14th of February on Valentine's Day. And we are going to explore and learn on the future of real love in the virtual world, the perfect date. So we will really explore the intersection between dating and the metaverse, and how the world of online relationship may evolve. So it will be an interesting and amazing session where we will find out a bit more about, how the future of love may evolve, and is evolving actually right now. So this session and all other events that are part of the digital transformation dialogues are really great opportunities to delve into new and exciting developments in the digital transformation space. And we encourage you to attend our future events. The ITU colleagues, my ITU colleagues, will provide relevant links to register in the chat. And thank you again for your amazing participation. And with that, I would like to declare the first Ask the Expert session now concluded. Thank you so much, Dr. Lee, and thank you so much, everyone. Bye-bye and see you soon.
Thank you. Bye-bye.